Okay, let's continue our discussion on molecular geometry. Just a couple more examples. Um, One of them AX4E. So what would that be a good example of? Well, if you think about it, that means you got four bonds and a lone pair, right? So ClF4, wouldn't that work? No, it won't work. So it'll be SF4 would work, right? Right? SF4 would work. Remember, sulfur is in group 6A, right? 6A. So it's got 6 valence electron. And fluorine is in 7A. So it's got 7 valence electron, right? And as always, the element that's least in count goes at the center. And it's got 6 electrons, so evenly distribute them around the sulfur. And you've got 7 valence electrons each on fluorine, so let's get a different color for that. And then we got our fluorine, which has 7 valence electrons. Right? Okay. Now, well, let's go ahead and connect them. Let's get our pink. So, red and a blue, red and a blue, red and a blue, red and a blue. All right. If you notice, we have a AX4E, right? Now, if you do go look at it, I know we did this molecule, I remember very vividly because we did do this in our electron pair geometry. Sulfur is clearly less electronegative than fluorine, so is all of them. You can actually do the math and figure out which one's more electronegative. Just look at the table, you get the answer. Now, the electron geometry, E dot G, for AX4E would be, we treat the E as a bond, so we said it's trigonal bipyramidal, right? Whereas the molecular geometry is AX4E is seesaw. Okay, now the way it really would look like would be, this is your X, this is your X, this is your X, this is your X, and your lone pair is the pole on which are the pivot point on which the A rests on. So this is your one side of the seesaw board and this is the other side of the seesaw board. Okay, so that's seesaw. So I don't want to go through and do every one of them, but there's a few that you have to practice on your own and see if you can do this. All right, so this is kind of the basic architecture of it. Maybe we'll do one more, I believe we have done that. So let's delete this, bring back, and we have time for one more. So let's do ClF5. Okay, so that Cl is Cl is in 7A, so 7 valence electron, and fluorine is also in 7A, so that also has 7 valence electron, right? Good. So as always, the element that's least in count goes at the center, so spread out the 7 electrons. I believe I have my math right. Alright, let's go get our blue, and we got 5, so just, we got 7 electrons on each fluorine. We split them into pairs of 2, we're left with 3 pairs and an odd electron. Okay, now let's get our red. Connect the red and blue and the black, blue and the black, blue and the black, blue and the black, blue and the black. Now we're left with 2 lone pairs, right? Now if you go to the Linus Pauling electronegativity table, you would quickly figure out that chlorine is less electronegative than fluorine. That's the same for all of them, right? So the electron geometry is very simple. We treat this as AX5E. Electron geometry would be octahedral because we treat the bond, the lone pair as a bond, whereas for the molecular geometry, which is AX5E, the E itself is not a bond, and that would be square pyramidal. And because of the lone pair, this molecule is polar. Okay, so far I have done bent, I've done trigonal pyramidal, I have done seesaw, I've done square pyramidal. Okay, now these are normal ones. Okay, so which we also have already done. So there's only one thing that I did not do, which is T-shaped. So I'm going to give you a couple of molecules in the homework that you can practice this and this. Okay, so there's only two that I won't be able to do because, you know, it just basically I don't want to do every single molecule, but you kind of get the idea, right? All right, so that's pretty much it for week 5, and I think there's a homework and a quiz based on that. So go ahead and give it a shot, and when you're ready, submit it, and then I'll look at it. All right, stay tuned. Bye bye.